Hi there, everyone. My name is Ruby Goodall, and I'm the lead producer of the AI and Tech portfolio here at Kosaka Research. Thank you so much for joining today's webinar hosted by the Confidential Computing Consortium and an esteemed group of experts to discuss enabling a greater data economy through confidential computing, a deep dive into real-world applications. We're really excited to hear from today's experts, and for all of you in the audience, if you have any questions for our speakers throughout today's session, please submit them below and our speakers will answer them at the end as we'll be having a Q&A. Without further ado, I'll hand over to our moderator, Sal Kimmich, Technical Community Architect of the Confidential Computing Consortium, to introduce himself and the rest of our panelists. Welcome, Sal.
Excellent, and welcome in, everyone. Again, my name is Sal, and at the CCC, I really focus on the open source projects, understanding why and how confidential computing works, and also understanding genuinely where it works best, which is kind of what we're going to be diving down into today. So today, as we talk about building a better data economy, I want to dive right in with our introductions and ask each of you to answer a bit of a question as you explain why you're here today. So, can each of you tell me a bit about yourselves, why you're here, and why confidential computing has come to be a center to the work that you do? Why is it that you care so much about this? So, Andreas, do you want to kick us off with that thought?
Oh, Sal, thank you for having me and for the opportunity to introduce myself. So, Andreas Waldwood, I'm the CEO and co-founder of Enclave, confidential compute company, and I've been in cloud computing since 2006. Before it, I believe, was even called cloud computing, and from basically from the early days on, we were always struggling with how do I trust what I see, and how do I trust that I can rely on the data and the quality and that it has not been tampered by anybody. And this has been a route, and with confidential computing, from my personal expectation, we have maybe for the first time something that can very easily generate the value that you can ensure that infrastructure applications are clearly separated. You can trust the application, what it does, quote unquote. Of course, if somebody gives you code that does something wrong, that doesn't go away. But at least you can exclude a lot of other things that reduce the trust in the third party, need to trust in the third party. And this is why I believe confidential computing, with the ability to encrypt data in all three dimensions, is a game changer, making the cloud confidential and can really make a change for the data economy. I believe we'll go into more details later on. Currently, I'm based in Frankfurt, so we're a German company. Just for the audience, depending on where they come from, that they know where to sort this.
Excellent. Your turn. Jump in.
Hi everyone. My name is Bertrand Foix. I'm the co-founder and CEO of Secretarium. And I've been confidential computing since the early days at the end of 2015. And we, at Secretarium, have taken this approach of using confidential computing to secure data, but also to demonstrate the honesty, demonstrate that you are processing data for a given purpose, and provide all the attestation that comes with that. So for us, it's really a way of doing a great paradigm shift in terms of computing, because it's a completely new approach to data processing and, as Andreas said, data economy. I'm French. I've been in the UK for 16 years. Secretarium is a London-based company. The entire team is working out of London. So if you're interested in confidential computing or privacy enhancing technology, very happy to get you in the office and have a chat with you.
Excellent. Simon?
Cool. Thanks, Al. So my name's Simon Gallagher. So I'm based in London. So I work for Microsoft, and I'm a technical program manager in the Azure Confidential Computing Program Group. And I guess, like some of my kind of esteemed colleagues here, I've spent most of my career in what used to be managed services, application service provider type organizations. I spent a long time at several large financial services institutions. And For me, I think the kind of promise and the interest and the reason for confidential computing is, I spent a lot of my kind of early career working with customers and stakeholders, having them understand how those managed service providers essentially logically separate workloads, how various controls are applied, how they can be evidenced. Really a lot of that historically has been based on trust and really a paper trail of evidence. Okay, and I think really the shift that we have now with where we see certainly within Azure, we're doing the kind of low-level engineering in terms of providing confidential computing, compute horsepower and infrastructure, is we're now getting to the point where we can get to hardware segregation within shared infrastructure, which is really important for scale of economies in these solutions. But not only that, it means it's a solution that customers themselves can independently evidence and can technologically evidence that they are receiving the protections they're asking for. So no longer is it really a right to audit or a turn up to a provider's data center with a checklist of what's happening. You're really able then to use the technology that's provided to get cryptographically signed proof which we call attestation, that really you are receiving the level of protection that you're asking for from your cloud provider. And then finally, I think really it's important for hyperscalers and many kind of cloud providers as we move across the market. It's one of these things that becomes something that actually starts to open up markets. It's kind of, I always see this as kind of win-win, right? Cloud providers really have no business or benefit in seeing your data, and customers don't want those cloud providers to see their data. So we see that as a kind of win-win for positioning workloads for the future.
Excellent. So I think we've gotten a better idea generally of how CC differs from perhaps other technologies, but I think it's important to understand how it's opening up opportunities and new markets and new areas. Simon, can you lead us in with understanding what exactly do we mean by a data economy? And then we can jump into understanding how that data economy and that idea shifts once confidential computing comes into the scene.
Yeah, so certainly I think the idea of a data economy isn't necessarily a new concept. I mean, I can think to projects I've done in financial services over the last 10 years, which, where multiple organizations wanted to collaborate on data together. You might want data from finance companies merged with data from retailers, for example, merged even with, government entities. And in reality, those projects always ended up being, to be frank, a kind of award-winning piece of legal work that didn't deliver much benefit at the end by the time you've been through the kind of data masking process and what can and can't be seen. And really, I think now we're getting to the point where we can open up multiple data sources to be collaborated upon, and that then starts to pivot some commercial opportunities on top of that didn't exist before. So if I think before, all of those kind of collaboration scenarios were very challenging to do in a meaningful way in the past, and really privacy enhancing technologies and confidential computing are really one of the things that enable those solutions to happen. So it's opening up, and we see a lot of interest in kind of new markets where collaborations are happening, where, say, previously they would have been very, very challenging to accomplish.
Yeah, Andreas and Bertrand, I think this is something where I'd love to dig in a little bit more. I have seen circumstances where we're able to work and compute over and bring together different data sources that we could not legally and regulatorily touch before without the protections in place. This is moving from a market of being driven from security and compliance to also opening up new opportunities. So my question to you all is, as we're looking at this, who are the major players in what we consider data economy as it stands? And as we move forward, what roles are you all going to play? And at large, how are we going to see a more privacy-oriented data economy using this technology? Andreas, Bertrand, want to jump in?
Sure. I'll start, and Bertrand, please follow up. So just to take the few dimensions. So the major players, of course, are, as Simon already elaborated to, a multitude. They're the data generating companies that, like the banks, the retailers, to take the things, but there are of course many small companies on the planet as well that generate a lot of data. The manufacturing companies who are still extremely hesitant to put their data onto cloud infrastructures as they fear significant IP risk there. That also brings me to the beneficiaries. So you have the infrastructure providers, you have the large data generators, and then you have a multitude of businesses that can benefit from it, be it advisory companies, be it service providers. So in general, if we have more trustable information at the tip of our fingers from a consumer to a business to a government, no matter at which level, we can make more intelligent decisions. And this is not even though it's a buzzword everywhere, it's not an AI question. It's about bringing the right sources that you can trust together that give you the right context. And this is also when we look at who wants to use this. It's on the one hand, the companies that are still in the process of turning paper to digital, yeah, and that don't want to do electrification, as some of my Austrian friends always say. They're doing not digitalization in the Austrian government, but they're doing electrification because they're basically just scanning paper and doing, instead of a paper trail, now a PDF trail, which doesn't really change something, but they're moving with new applications. These new applications rely on data, and if this data can be made available for next processes, even within the public sector or between public sector and its peers, we already have a significant gain in value. And that's where confidential computing can make the difference because it can protect the data and it can accelerate the transition at the same time. And the big infrastructure players like Microsoft can enable that and are enabling that by basically providing the capability to the mediators that ensure confidentiality, attestation, etc. is given, like Clave and Enclave, and to the application owners who build the application on top of that, giving the trust to public entities. And that's where we see current demand growing and understanding growing, as well as has been an educational roadmap for the last 4 or 5 years. Yeah. Maybe this as a more general thing, but Bertram, please. Yeah.
Yes, confidential computing really provides this transparency on how data is going to be processed. You know exactly, the business logic on the other side, exactly what's going to happen to your data. So if whatever solution you provide has some policies and limitations enforced, then you have the guarantees that your data is going to be processed in a single way. And if you look at a bit in the past, back like 20 years ago in the financial market, for example, you had like financial market data that was aggregated by some of the banks, and then they were setting the benchmarks at the end of the day. And these banks were constantly, accused or suspected of doing market manipulation. So one of the solutions was to transfer this market price aggregation to a third party. And then you had Bloomberg, you had Reuters, and others that have taken this gigantic market and are now taking data from all of the banks and aggregating that and then creating the financial market prices. Same happens to Meta, Facebook. They take data from individuals, they aggregate that, and then they package it in a different way to monetize it. But in a sense, with confidential computing, when we say it's a paradigm shift, there is something very different. A bank could now go back to be this aggregator because they can now demonstrate, with all the transparency, with all the auditability, how these market prices are computed. And same will go for a social network. So the players that you had 20 years ago have been forced to change the way they were processing data. There's been a massive boom in Web 2 with massive data aggregators. And I think now we are maybe opening a new era where data will be processed, and the players of tomorrow with confidential computing could actually be very different from the one that we've had over the last 10 years.
So I think there's so many cases where it's very clear that this makes sense, financial, healthcare, we see anything where privacy has been a concern, or these emerging sectors. But as a quick stepping back, as we step into this new data economy, this new space, can you explain how the average consumer, the average end user might be experiencing a different experience here? I think specifically I'm seeing a lot of work being done in the financial space, both in the market exchanges, also in fraud detection, being able to aggregate massive amounts of data that we could not share before. Do you think this is going to have a positive effect on consumers who do not consider themselves engineers? Is this going to impact the average end user? And in what ways, what do you think?
Yeah, so there's always this big, sorry. Andreas, do you want to, yeah, go ahead. Go ahead.
Okay. So as you asked for the consumer, I believe the consumer will experience two things if we do it right with confidential computing. The one is he will get a clearer view of what is his and what is not his, and he can control whether it's his or not his, which theoretically we can do in many areas today, but it's very complicated. The second part is we will, from my point of view, we will see very attractive new services. Attractive new services that I, as a consumer, can use. And I give you a simple, because we've been talking about financial services so much, I'll give you a simple financial services example. Today, there's a significant constraint what the banks are theoretically allowed to do with my data. But they have a lot of data from me. So I could either go into some open source or downloadable some things and try to do something on my own, or I can find advisory services that, even though we have PSD2 in Europe and so on, so there's some data sharing between the banks, but still this is at a level where if I want to do anything with the bank, I start with my documents from zero. Even with sometimes if it's the bank I've been for 15 years or so. And that can change, because suddenly data becomes trusted, becomes digital, becomes shareable, and can say, bank, here, you have that data, let's analyze that, and I give you this view, and this company provides the trust tool on it. And this runs on a trustworthy infrastructure and on and stays confidential. And I can also remove that again. Yeah, and it's not because of a paper trail or because somebody said there's a law on data protection or privacy protection, but it's because it's simple and the tool. And this is something where I believe the consumer will benefit from it. And let's say a personal hope is, of course, that people can begin to monetize, or at least commercially benefit tangibly, and not by free usage of a search engine, but by other things, from the data they put into the system. Yeah. So just that much for me. Simon, you were looked like you wanted to jump in.
Yes. To me, there is a big difference in that you always have to hand over your data to the third-party processor. You will hand over your data to Facebook, you hand over your data to your bank, you always have to, even when you buy something in the internet, you hand over your address, your phone number for the tracking of the parcel and everything. And you don't know where your data goes. You have no control on that. And it's sometimes, there is a big data leak and you end up having your password or your phone number on the internet and start receiving some spams. It's a bit of an annoyance from a day-to-day point of view, but it's not too critical for this kind of data. It's critical, but not that critical. Now, if you want to go beyond, like if you want to actually have your genomic data analyzed by a third-party provider because you want to know whether you could develop a certain sickness or certain, or you want to know, relationships you could have with some people. That's another story, because your genomic data is not just your data; it's also your parents, your children's, your siblings' data. So you actually giving away data that is not exactly just yours. And if it falls into the wrong hand, it could actually end up with a larger insurance premium for you and stuff like that. So, there is different levels of criticality in data. Many of the population today, they are worried about privacy, but they still use Facebook. They still use, these big platforms, and because the benefit they get from that are better than the occasional privacy issues. But there is a very large panel of services that just do not exist today, because these services would need more sensitive data, like your salary and some more information, some more precise information that you are not quite willing to disclose to anyone. So confidential computing, another privacy-enhancing technology, would actually allow this new type of services to be created, and maybe we are actually in front of a new generation of personalized, very personalized services for medicine, but for everything else.
So we've talked a little bit about a few sectors that are both changing or emerging because of the data economy that we could make, a more privacy preserving or privacy oriented data economy. We understand a little bit more about the consumers and a little bit about how that could change the experience for end users as well. I think there are a lot of cases where we are going to see, personalized and also much more interesting aggregate or global scientific work could be done if we could share this in medicine. That's why I'm very interested. So while we're looking at that, as this data economy that we are going to be stepping into in the next 5 years, what needs to change and to make that happen? What needs to be improved? Where do we need to be looking? Does the attention need to go to cloud service providers or to ISVs? Is it an open source problem or is it a regulation problem? Which of those or all of the above would each of you think are going to be the most important elements as we move to that new reality?
I think if I could say that, I think it's probably all of the above, right? It's one of those things. So we certainly see at the moment, regulations are typically slow to move with these sort of technologies, and obviously it's not something they can generally recommend for broad adoption until it is generally, consumable. But certainly, in the work that we do at Microsoft, we see this already working its way into various regulations around the world. We see specific mentions for confidential computing working its way into that. But it does also mean that the tooling needs to be available and it needs to be proliferated and available for people to use. So I think there's work that we as the hyperscalers can do, obviously, to make that broadly available, which I think for Azure we're certainly doing a good job of making sure that that is there. But the tooling then for people to be able to build solutions upon it, because I always kind of see confidential computing as a kind of a building block technology, right? It's an enabler for the things that sit on top of it. It's really providing an up-leveled kind of hardware platform for things to sit on.
So
one of the go ahead, Andreas.
Sorry, Bertrand, we always overlap. But the all of the above, of course, is the correct answer from my point of view as well. But I would like to take the step a little away from the regulators, because we have become so used to wait to implement until the regulator requires me to, and then I have another 2 years, and then I get an audit finding and have another 2 years. I believe the ISVs need to embrace that, because what we see in our discussions every day is customers love it. When you tell the story, the customers say, great, where do I get it? And then you say, okay, Azure out of the box, and your temporary market companions with the other two names as well. Well, the last one just opened their box at least. So you find it in the hyperscalers, you find it in some local data center providers as well. slash, which brings the ball briefly, the CSPs. If you take the top three, they all have it. If you go one level below, it becomes a lot scarcer. And if you go to local data center providers, some are even saying, no, we're not going to do that at all, because we're national anyways. We don't need that. But still, if the ISVs basically understand how simple it can be, yeah, and this is what we've been working and focusing over the last 24, 36 months, is to say, this is simple. It's not a reinvention of the wheel and you need to build everything from scratch anew. You can, of course, but you can make that very simple usable. It's the ISVs or the software development partners of large enterprises, which are kind of in-house ISVs from my point of view, need to understand how simple it is to embrace it and deploy confidential workloads in cloud infrastructures. And if we get that done, I believe, as Simon mentioned, that the regulators will follow suit as they then put a caveat and some auditing features around that, and then they will move this way. And this is what we're seeing, at least in some discussion with the regulators, that they're trying to find a middle ground to enable a roadmap that gives this, where the gap is not 5 years anymore, but maybe only a half a year or a year between the cycle. Because trying to say, you don't need to go all the way to complete full confidential, you can start and do it in a step-by-step approach. And that's why I believe when the ISVs provide SaaS as a confidential solution with some nice connectors to auditing and key control and access control, that will be a significant accelerator, also driving demand with the hyperscalers or other cloud providers, and customers will simply buy it, yeah, because they love it. The story is simply great, yeah. But they also say, where do I get it and where can I run it, yeah.
So
that's my view.
We need to be changing the story, because as I've spent more time researching and working with confidential computing, I find so many examples that do not just demonstrate privacy or security. It demonstrates a completely new way of being able to do nuanced collaboration that we have not been able to touch since we had access-enabled collaboration. What are some examples that are strong, positive examples that we can really be taking out there? What are some of those things that you all find inspiring? I will start with the one thing that I think was really interesting, that we have been using confidential computing to assist with human trafficking, being able to bring together different data sets and put them into a space where we can get good information out of them without ever disclosing those victims again. I think that's incredibly important, and that work would not exist today without confidential computing, period. We need to be telling the stories like that because this is that important. For each of you, is there something to this story, something to this technology that shifted your perspective, where it was not just about data privacy anymore, but to where it was about enabling of new forms of collaboration?
Yes, there is a number of use cases that are extremely strong. Like, for example, well, there's been a lot of issue in the movie industry for a long time, and a lot of people couldn't be vocal about a thing that happened to them. There is a use case where in universities where you, if you have sexual aggression, you will actually register that in a confidential computing service. There is nothing, unfortunately, most of the time there is nothing quite you can't prove. So nobody is listening to you. But as soon as a second person is the victim of the same aggressor, then you've got a more compelling story, because you can actually bring more proofs to the table. And this is, I believe, the kind of use cases that really make us wake up in the morning and work harder, because that kind of instantaneous good impact on society. But there is hundreds and hundreds of use cases. Like back in COVID time, we applied confidential computing to contact tracing, for example. So we could actually learn from exposure to the virus and run some and calibrate some AI to better understand, what business could remain open and what business had to close, unfortunately, because they couldn't provide with the conditions to reduce the risk of contamination after exposure. But all sort of this technology require a lot of data, and nobody wants to create a mass surveillance system where all the citizens will say where they've been at what time, etc., etc. So again, confidential computing is quite strong. And then you've got all of the financial crime data collaboration as well that are extremely important, because ultimately all of the frauders, all of the scammers around the globe need to launder their money. So if you cut their capacity to launder their money, then you actually greatly reduce all sort of crimes that is built on top of that. And that is ultimately a great goal to achieve as well. That's Simon?
Yeah, thanks. And Sal, you kind of touched on one of those cases earlier, which is really in the kind of healthcare space. I have to say, prior to kind of moving out of financial services and being a bit more broadly applied across other industries, I hadn't really appreciated actually how difficult it is to take medical data sets, even between different hospitals, and use them to work and collaborate in that kind of healthcare space. There's a lot of kind of IP and privacy issues, and it's very similar to the early days of us doing this in financial services. The resultant data set tends to be not that useful, because certainly for biomedical science type use cases, you need that full spectrum of data. It may well be this particular gene sequence or combination of socioeconomic data that impacts the outcome. And really, this is, I think, one of the technologies, the technology really that makes that possible. And it's not just about financial services organizations making more money or doing more efficient things. These are things that deliver actual real world life outcomes. Is brought on by technology, and it's not something I think you can do without these kind of technologies.
Yeah, I like stepping back to some of those examples just to be sure to let anyone who's on this video call understand that they most likely have already engaged with an infrastructure that uses CC, and for good reason. So I'm going to take a little bit of a shift. A little bit of a follow through. I am very excited about the explosion of AI and medical research. I'm also really interested in how AI is going to intersect with confidential computing. So everyone's favorite buzzword, Gen AI. How is confidential computing fitting into this? And is it making a really big difference to some of the things that we can compute over GPUs?
I can comment sort of fairly briefly on that. If you think about all of the corpuses of data that those kind of language models, with generative AI depend on, right? In their own, none of them are necessarily particularly sensitive, right? But when you bring vast data sets together and you start computing against them, you get this kind of, through data concentration, you get what was previously something fairly innocuous. You get combinations of data that you previously hadn't foreseen. You might have your staff Christmas list with the Christmas party list combined with a customer list combined with Wikipedia data combined with medical research data, and that may well yield results that lead to people being personally identifiable through implication of stuff. There's we publicly talk about a lot of our kind of AI safety frameworks and responsible AI, but putting all of that stuff inside a trusted execution environment, as you get with confidential computing, is really one way of up-leveling that. Because you're looking at kind of GPUs, which is really what you use and have to use to run this stuff at scale. This is stuff that you really have to start doing in the silicon, so fairly low down in the platform, not purely in software.
Andreas, were you about?
Not much to add to it, besides the fact that we're also seeing use cases in the AI space where customers ISVs in this case are talking about protecting their IP. So it's not just running against large language models, but having very smart, let's say, analytics platforms in front of those, where customers say we want to leverage confidential computing to protect our IP. In this case, so not a curious customer can quote unquote snick that part of the game. So it also has the other dimension, and not just the value of the collaboration, which of course comes as Simon just described it, but it has also the IP protection dimension. And we see that also very much in the manufacturing industry, again, as mentioned earlier. They have untapped pools of data of huge dimensions. We don't even know, we're just at the tip of the iceberg and we have no clue what's possible. And there is so much potential for improving products, for improving processes, and improving also sustainability, supply chain visibility, and taking all the other buzzwords that are beyond AI out there in the manufacturing world, where confidential computing can really build the trust layer and foster IP protection in our manufacturing chain, which is certainly something very interested to everybody who is trying to build something and have it not copied by somebody tomorrow. As the difference in many products is not that you cannot build that, buy the product and copy it, but that the challenge is copying the production process and getting the production data and the tolerances and the faults and all that stuff is very valuable. And this is something where confidential computing can really bring us to an industry 4.0 level that we've been speaking about for something like, I don't know, 5 years, 10 years, I don't know, quite a while forward, as we break down this firewall, this mental and technical firewall between the IT and the OT world at that stage.
Yeah, I also think that when I really got interested in this problem at first, I was working on big data sets and combining big data sets. And there is a concern called unicity. It starts with a U. You can calculate how likely you are to find an individual or a group of individuals based on 2 or more data sets. And I became aware of that at National Institutes of Health because they would not release a cancer data set because it risked unicity with a data breach from Netflix. I think we're all very aware of the conditions right now where it's clear that there are conditions where privacy has always been important to that as privacy protected information. I think we're going to discover a whole set of classes around individuals' information that may need further protection as well. I genuinely believe we're going to find more circumstances where confidential computing is necessary, because AI is not just about what we are doing it on our side of corporations and nonprofits. It's also about what the adversaries are able to do with it. Protecting your compute and protecting your algorithms is more important now than ever. Confidential computing is the only thing that's offering you that, in my view. So I think that we've covered quite a few of the major topics that I wanted to step through. Is there anything that we are missing that we want to cover before we jump into some really interesting questions from the audience? All right.
Let's hear the audience. I believe that's much more exciting.
Yeah, I think this one's interesting. And I'd love to hear an answer from each of you. What recent technological advancements have significantly impacted the development and effectiveness of confidential computing? And where are these advancements expected to evolve in the next few years?
I guess maybe I could take that first, right? And so for me, I think it's, so if I think back to when I first became aware and started working with confidential computing technology, which was probably, I don't know, 5 years ago. So I think for me, it's the point where it's when confidential computing first came along, it was only ever able to take advantage of very small amounts of compute resource, very small constrained areas of memory. And you had to develop your application in a very specific way. You had to write to specific frameworks. So if you are an organization looking to take advantage of it, you had to do some fairly heavyweight refactoring, or at least kind of restructuring of the way your applications are put together. And what we've seen within probably across the last 18 months, and the roadmap for this goes out quite a long way, is that it's now much more possible to take an existing workload, an existing unmodified application, and deploy into a trusted execution environment and inherently benefit from those kind of platform security features that you get through confidential computing. So, if I think back to all the things that, you used to do within applications, if you wanted to do something specific, you had to write a specific way. That over time, that got kind of up-leveled and dealt with by the operating system or the application frameworks. And I think for us now, this is really where confidential computing is really moving into that space. And that's what really starts to make this a kind of ubiquitously available technology, is well on the way to becoming a ubiquitously available technology.
Yeah, on our side, I think I need to present a bit of the platform that we've built ourselves, because we started confidential computing in the early days, and it was really complicated. You had the SDK was very limited, the hardware was very limited in memory as well, so it was a very constraining. But with time, it actually started to get better. To the point where last year we were able to deploy a confidential computing platform to really ease the adoption of confidential computing for all developers, so that even if you don't have any knowledge of the confidential computing, of hardware, even of cryptography, you can actually build your APIs online and click deploy that on the confidential computing platform, and instantly your service runs on secure hardware on the cloud, and you've got all of the attestation to demonstrate the honesty of your service, to demonstrate that data is going to be processed for a given purpose and nothing else. And that, I think, is really new, because there are not that many confidential computing platforms at the moment. There is, of course, the lift and shift that are pushed by the big cloud providers. You will actually have an entire virtual machine that is running on confidential computing, and Intel TDX is going to push that even further in the next few months. We took the opposite direction. We went to WebAssembly, and how we could actually take third-party business logic, compile into WebAssembly that runs inside an enclave. So it's actually much lightweight, and it allows you to focus just on your business logic, just on your data process. You don't have to deal with all of the DevOps that are coming with virtual machines and different shift approach. Apart from that, yes, attestations are getting better and better, much better than the early days. And I'd like to thank all of the confidential computing ecosystem for that. It's getting really nice now. So
to close the round, maybe just two things have been said, or many things have been said around the evolution. If I look forward, what I really find relevant for the evolution is that all major chip technology providers will provide chip technology that is CC enabled. Yeah, so we've spoken about Intel, we've spoken about AMD, NVIDIA, ARM will follow, and with a delay, hopefully also RISC-V. This will make it omnipresent from the edge to the data center. Yeah, and edge computing in this case, I don't mean necessarily your mobile phone or your PC or laptop, but I mean all the edge devices that you see out there generating data, doing pre-computation. The second part is that at least the big three hyperscalers have now agreed, whether implicitly or explicitly, I don't know, to offer confidential compute services that are not equal, but very close to equal, that providers like us can basically offer a neutral cross-platform deployment capability with a single trustable attestation service. Yeah, and we can leverage what Microsoft and Intel are doing, what other companies are doing to provide a single neutral approach to it, and giving the flexibility to deploy specific or lift and shift or just anything in the middle out there. Because if it becomes seamlessly usable for the operator, and you don't have to change your development tools and your development processes for that, then I believe we will also see an acceleration of the adoption again from ISVs and customers.
So we have one more question from the audience that I'm going to alter a little bit. The question is, what do you think about federated learning and the risk, and here's what I say, and benefits of this technology for that use?
Yeah, federated learning is absolutely perfect for to learn from sensitive data when this data has no correlation. For example, you're looking at medical imageries like scanners, and you will actually calibrate your AI to detect some potential sickness. All of the information is in the image. And by calibrating your model locally, you can then, with federated learning, improve the models that are calibrating in different hospitals or jurisdictions, and together achieve a better model. But this is not applicable to all of the data, unfortunately. If the data has a bit of correlation, like if the data from one silo needs to be as correlation with the data from another silo, then federated learning will not allow you to learn from these correlations. And that is actually quite often, that unfortunately quite often happens, meaning that everything related to anti-money laundering, fraud, like scam and so on, is highly leveraging correlations between the data. And this you cannot capture with federated learning. So, and it's like with all of these privacy enhancing technology, they are very good for one or two purposes, but they are sometimes not applicable at all to other purposes. So it really depends on the use case, federated learning.
Any other thoughts on that question? I think that's a really good question, and I think it also, if we could dive in more, there's understanding cross-border data collaboration, all of the regulation, all of the limits, and everything that is immediately available and possible if you secure it in this way. So as we start to wrap up a little bit, I want to offer each of you a sort of two-part question, and I also want to tell the audience that send us any more of your questions, and I will make sure to catch them after this. But I sort of have twofold questions. The first is, what has been, up to this point, today, 2024, what is the thing that you are focusing on, whether it be a sector or a solution or the technology? What is the thing that you are going to continuously keep your attention on in the next 2 or 3 years to make sure that this industry works? And then, assuming that we all succeed and confidential computing unlocks a privacy-oriented data economy, in 2035, what is the one thing that you are most interested and excited to potentially be an end user of? What can you see yourself being impacted by with CC as a standard? Jump in, Simon.
Okay, I'll start. Give me the alphabetical order. I'll start. So what are we focusing on? We're focusing on to make it even easier to deploy in a broader ecosystem every day. So if we think about where do our development dollars go besides single projects, it is making it easier, faster, and more ubiquitous to use. So not just with the hyperscalers, but with the local players, and to make it much easier to integrate with the applications. We are working, if I'll take 2 more steps from the roadmap, we're working on also being able to integrate your private data center or your private infrastructure into a single confidential environment without having to rebuild the whole stuff. Of course, you need to have the right processor technology, but in case you want to have something in your own cellar for whatever reason, because you like it blinking, you generate too much power from your solar panels on the roof or whatever, the reason might be, you can integrate that into a single confidential environment. And last but not least, we're working hard to be post-quantum confidential ready, because it is a topic not just from the regulation but also from the technology, and working here with some PQ companies to make sure that we have the right algorithms in the backend ready to go, because that is something that is very important around this. So this about that. Then just, well, it pops up on, even though you're reading the question, it says GDPR in the EU. Yes, it is compliant. There's a legal paper. If you reach out to me, I'm happy to share that afterwards, from the University of Bremen. And of course, it reduces your effort for technical stuff in your TOMs, because it brings some things makes some organizational measures technical. So your TOMs in terms of complying with regulation becomes flatter. It doesn't go away, but it becomes flatter. And GDPR compliance and confidential computing, again, there is from Dennis Kopke from the University of Bremen. There's a study, happy to share that. Last point, Sal, to your question, 2035. I could say I'm so old, I don't need to worry about that anymore, because then I'll be sitting at the beach enjoying the weather, and who cares? But from a technology perspective, I basically, if I get up and use stuff and don't need to worry about what happens with my data, then confidential computing has really moved it to the level I would love it to be. Yeah.
Excellent. Bertrand?
Yes. So our focus is, as an infrastructure provider, our focus is on improving the confidential computing tools that we provide for developers to really make it the technology that's easy to adopt and cheap. As of today, if you want to build a website, you rent a virtual machine, you pay like £2 or £5 per month on a cloud provider. You launch your Nginx and you have your website online. It's really straightforward. Confidential computing is not like that at all. Machines are more expensive. There is a lot of engineering to do. It's a bit too much, and the entry barrier is quite high. The Clave platform that we built, and is going to continue to be our main focus for the next few years, is how to reduce this barrier and how to make it super easy for developers to bootstrap something in a few minutes, and then build from that. So that's our focus. And in 2035, in 10 years' time, ideally, people will have their personal data in a wallet, in a self-sovereign wallet. They will be in control, as Andreas said. They will not have to worry about anything like that. They will be able to enter their home from their phone, but Google will not be able to unlock their home. They will be the sole controller of their properties. And all sort of services like that will really be game changing. So yeah, a very big shift into data ownership and control.
Cool. And then, so I think from my point of view, definitely focusing on making it ubiquitous, right? And transparent, cost neutral, easy to adopt. And, in the same way as that nobody really thinks these days specifically about technologies like TLS or, encryption at rest. It just happens, right? And really, that's what we are kind of relentlessly working towards doing. And then, also using it to secure services across the board. But if I were to think about maybe more interestingly, if I were to think about what I would be really looking forward to in 2035 that this would have enabled, I would hope that my flying car will be self-driving. It will have learned on interesting video data sets that it can process in a privacy preserving manner, right? You think about all the video that cars with cameras gather, if you can use and complement it with that technology to ensure that all privacy data is protected as part of that. If I want to mash that together with some kind of large language model and make some horrendous prompt about where I want to go and have it make it do for, that's, I think that is the kind of technology that really moves us on from where we are today.
Well, that's an exciting future, but it would be a secure one. Well, I think with that, we've got all of our questions covered. I am happy to wrap and thank all of you so much.
Thank you to all of our panelists and Sal for moderating. That was a really, really great, interesting session. For anyone in the audience, if you'd like to hear more from the Confidential Computing Consortium, catch them at our next Privacy Enhancing Technology event in Singapore this July in APAC, and you'll all have a follow-up email with more details on that. Thank you so much for all our panelists. End of the session.
Thank you.